The RiverJetz case problem walkthrough. Okay, part of the magic of this problem is laying it out properly. So I laid it out with a B column, an S column, and an XT column that go all the way down. So everything's always lined up. So here we have the wholesale price, the price that they buy them for BS and XT. Then we have the sales price, what they sell them for, and the liquidation price, what they sell them for when they can't sell them to customers. Finally, we have total demand, which is kind of set up as an input, and percentages, which are also set up as inputs, so that the exact number of prosumers and price shoppers are calculations made from the total number of consumers and the percentages. Fair enough. Now, the order quantities of each are set up here, and unfortunately, what I have here is the optimized version. So 1900 and 3300. But at any rate, what happens is that because prosumers first buy XTs, I have an equation here where it compares the number demanded to the amount that we have in stock. If we have less in stock than demanded, then the amount that they buy is what's in stock. If we have less demand than what's in stock, then they buy the amount demanded. So here they're buying what's in stock, and 1300 minus 1300 is 0. They don't buy any of the rest. And I subtract the 1300 from the demand to get 650. So 650 is now my residual demand. The thing that they buy second is the S's, and so it's the same thing. We compare the amount of residual demand to the inventory of S, and what we sell is whatever is left over. So here it's 650, and 2300 minus 650 is 2650, assuming that that's the right quantity. And actually, I believe that has changed, but we can talk about that later. It doesn't matter. We're going to optimize it anyway once we get to the end. And so we have, right now, on this model, I have 1900 B's left over, 1350 S's left over, and 0 XT's left over. And third, if they bought B's, I would put it here, but since they don't buy anything third, I leave this static. So I still have the same amount of B's and S's left over, and all of my demand for prosumers has been taken care of. Now we take care of the price shoppers. And it's kind of the same thing. I take my demand for price shoppers, which is 45.50. They buy the B's first, using the same basic equation, where I compare the amount of B's demand, the amount of demand to the inventory of B's of model B. So I sell my entire inventory of B's, so I have 0 B's left, and I have 2,650 people left who haven't bought a jet ski. Second, they buy S's. I sell out of all of my S's, leaving 1,300 people, 1,300 units, people who are potential units that we could sell that we didn't sell, which is why I believe that this particular solution is not the best solution. To figure out what my retail revenue is, I multiply the number sold of each unit, which was the number bought less the number left over, times the retail price, which gives me my revenue for each one. And then I multiply the amount left over, which is this row, times the liquidation price to get my liquidation revenue. Adding them together gives me my total revenue. My cost of goods sold is the amount bought times the amount of the wholesale price, the amount that I buy them for. So it would be the 1900 times the 2600 in this case. Gives me my cost of goods sold. The difference between the two, strictly speaking, is called gross margin, but since we have no other expenses here, we'll label it gross profit. give me a total of $5.8 million in gross profit. But what worries me is this 1,300 left over. So if I go to data and then solver, I set my objective to be my profit. My changing cells are my order quantities. And my only constraints are that my order quantities need to be integers. My order quantities need to be greater than or equal to 0. And then I hit solve. And what it comes back with is saying that the optimal sales is to get 4,550 S's and 1,950 XTs, which will make us a total of $8.4 million with nothing left over. Now, the bonus question was to create a parameterized model that will allow us to change what the preferences are. So what I did is I took, in this one, for instance, the first purchase was hard set to be XT. I had nothing in these cells. And the equation was one that compared the amount demanded to the amount available. What I did here is I created a new area with my preferences. If it's the first preference, it's a 1. The second preference, it's a 2. And if it was the third preference, it was a 3. But if they have no preference in that they won't buy it, it's a 0. And so when I come down here in the first area, first I test each one to see if this particular, like here, we're testing the S value for preference to see if it's a 1, because this is the first thing bought. And for each of these, the answer is no, but for this one, it is a 1. So I buy 1,300 XTs. If instead I set B to 1, it would change the values accordingly. And the same thing going down. And so now we have a third category in case we have any that we have some leftover usage that we want to sell out. So let's say we're sitting here and we're looking at 7,000 XTs. Now I would sell out all the ones I have to the prosumers, so we took care of all of them, but we still have the ability to sell them to the Priceshoppers. So if I had a 3 here, now the Priceshoppers would buy at least some of those XTs if it were a choice for them. But in our given model, these are the preferences. And if we run solver, we'll get the same result, at least right now, because everything else is the same. It's just that we've now created these parameters. This is the solution for RiverJetz.